All right. You should all have a copy of my repository, but I want you to do some reset because I made some last-minute changes. If you do git fetch, you should get all recent information, like tags and other stuff. And if you then do git reset 1.0.0, which is the starting point of this application, --hard, you will make a full reset and start at this version. All right. Cool. So with this done, we need to install some dependencies, the usual suspects. Composer install. This is loading from cache for me, but it's pretty quick. And npm install. Anyone not getting this? Hulp nodig? Right. Version 1.0.0. Good. What is this? Okay, npm. I don't care about this. I need to run some npm tools, so I do npm run dev, and that will compile my front-end assets. And that's all of the front-end stuff I will do today. So npm run dev. So for the people who turned up late, I did git fetch. Git reset 1.0.0 --hard. I also did composer install and npm install. And then last front-end stuff is npm run dev. That's all I did. I'm going to wait a few more minutes. And then the last step to get this working, because right now I see some errors, is I'm going to copy an example.n file to a real.n file. And I'm going to run this command, php artisan key and generate. This will create a secret key to make this application a little bit more secure. It's just a dev version, so it doesn't really matter, but for this framework, we need this to work. Oh, hey, this is a Laracon tutorial. Apparently, I did this tutorial earlier this week. So this tutorial is based off of Laravel. Don't mind me. I was just too lazy to rewrite it in a decent framework. OK, cool. So this application is a Twitter Bootstrap application, super basic. It's like a base of a CRM or a web shop, whatever you want to model here. And it has two models, products and suppliers. And for that, we are going to create a database and just randomly seed it with 30 products or 32 products and 5 or 6 suppliers. If we go back to our CLI tool, we can do PHP artisan. Wait, let me clear this up. PHP artisan migrate -- seed. Did you ask me to slow down? Right now I can check out some products. Oh, by the way, I don't use Apache or something. I just use this line to boot up a server and to boot up this application. I don't need a web server here. This is not a production environment. So for development, I use php-as, then an IP address, a port name, and -t or -p public to serve from the public folder. If you do that, you can go to localhost, your own port name, and then you can check out this application with its seeded products. You can see that there's multiple pages of them, and there's a search bar. So if I type something, I can search for stuff. Right now, that doesn't work, but we will implement that as soon as possible. Is anyone not at this phase yet? There you go. I think we're all set. Anyone else having issues still? No? Good. That's the first time it worked. Cool. So, this is a super basic CRUD-style application. I have a controller, I have a command bus, I have command handlers, etc. I can list all the products, I can paginate products, I can search for products, I can delete products. Let's delete this one. And I can create a new one. So there's a new keyboard with a US layout. It's by Apple, so it's pretty expensive. I have 0 in stock. There you go, I have a new keyboard. It's in here. It's the last item. So that's pretty basic. But if you have a ton of pages of products, the people who are working with this application, they want to find their products super quick. So they want to be able to type, for example, airport, and all the airport, Extreme and Express, and all the other products should pop up as soon as possible. Right now, this application is built in Laravel, and it's connected to a SQLite database, which contains 2 tables. Let me show you the tables. Well, 4 tables to be exact, but products and suppliers are the 2 main tables. If we look at suppliers, there's Apple, some randomly generated Juliana, Ellen, Alda, Kenyatta. They're all suppliers. And we have products, which have a UUID, a name, a description, the price, stock, supplier ID, and some timestamp. So the supplier ID is basically a foreign key referencing the suppliers. So these first 2, Airport Extreme and Airport Express, they have the same supplier ID because they basically point to Apple. So that's how we do relational database stuff in MySQL, or SQLite here. So our primary data store is SQLite. So we're going to try and build this search functionality as good as possible using the existing database technology that we use in this product, right? That's the first step. And for that, I'm going to use this illly named MySQL query class. If you want to find it, it's in app/products/queries MySQL query. The class is already there. You don't have to do anything. But I just paginate all the products and return that to the controller, and the controller renders the view. But the search item here, the search term, is not being used at the moment. So that's our first step. We're going to use this to build the search as good as possible. So what do we do in SQL? We do a like query. That's the super simplest form of searching on text. We're using Eloquent ORM here, which is ORM by Laravel. It's not the best, but it provides us with a super simple query interface where we can just fluently add more where clauses, etc., etc. So I'm going to quickly demonstrate this here. So for example, we have a name field, a name column, and a description column, also an ID column, and we also have the name of the suppliers, but those are in a different table. So we'll get to that later. First, I want to search on name. So I do name, like, and then I do some weird stuff with some percent signs. Let me use PHP as a templating system. I'm going to search for it here. So right now I search for the name when I have a valid search term entered in my search bar. So I'm going to paginate again so that I can get a paginator and append the queue is search query string. So what this will do is if I type airport, this will find me all the airport items. Airport. Whenever something is part of the name, I will get a list returned with all airport items. So I can also do port space X or X3. Those are all substrings of airport extreme. So it returns me this product. Also note that it's case insensitive. So if I type a small e, I can still get airport extreme with a capital E. If I make a typo, for example, airport, but I forget the R, it doesn't show up anymore. So airport without an R doesn't really give me the corrected version. So that's one downside, right? Let's add searching for description and searching for ID as well. So we're going to do an or where here, because it doesn't have to match and the name and the description. So we do or where description like. This is just copy paste. Or where like description is also like the search. So if we do Wi-Fi, we should be able to find all the Wi-Fi access points, right? If we type airport, we still find all the airports. If we type Delorum, we find all the Delorum products, either with Delorum in the description or Delorum in the name. It matches both. Now the next, we want to match on the ID. The IDs are basically strings, UUIDs. So if some client comes in and or a consumer comes in and he says, I saw this product with ID blah 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 on the internet and I want to buy it, then I want to be able to type in the same ID and find the same product that the client was referring to, just by typing in a few letters. So if I type in this, I want to see the exact product. Let's do this. Or where ID like search. Super simple. And it works. Right? It doesn't work? Can you add some context? Why?
Exactly the same thing you did.
Uh-huh.
And it doesn't work. So
wait, can you show me again?
Search is empty, it goes. Air.
Can you show me again?
Yes. So.
Oh, you need a $sign here after percent. Because you want to use this search item here. Yeah, in the variable, you want to use this as a template. Okay. Does it work now? Can you check? Perfect. Good. So we did the basic search on ID, name, and description. Now let's make it a little bit more difficult. Let's use a supplier name. I want to search for all products for Ellen. Ellen is one of our suppliers. And that's pretty weird, because Ellen is also part of this description. Doesn't matter, we're going to search for Ellen. So, how do we do this? Can we do like supplier.name? Nope, doesn't work. Doesn't work like that. But what we can do is we can do some joins, and we can do a where supplier.name. But there's also like super sugar syntax stuff, where we can do where a product has a supplier, and then we can add an anonymous function, pass in the search term, which takes a query object, a query builder, much like one returned by where or where. So we can do the same thing. Where has a supplier for which the supplier has a name, where name, like basically the same thing. Where name like search. If we print this query, it's going to do a join, and it's going to limit the results where the supplier.name is a like search. So right now this should work. If we search for Alan, we get all the products for Alan plus products for Ada, because Ada has a description. Ada has a product with a description which matches with Alan. So that's that. To be honest, this search works. If we type in 900, we can also see the same product because 900 is part of the ID. We can fix that. We can tweak it a little bit. We can remove the percentage sign here to make sure that it starts with 900. Doesn't work, so we have to type in CB8 900 stuff, and it still works. We can tweak this. We can improve this a little bit, but there's some stuff that just doesn't work with SQL. For example, if I type in Apple Airport, it doesn't work. Why? Because the supplier name doesn't match with Apple Airport, although it does match with Apple, and the product name doesn't match with Apple Airport, but it does match with Airport itself. So it's not going to fragment stuff, and it's not going to help us with our search. It's going to just say, does this literally contain the string or not? If I type in if I make a typo, airport without an R, for example, it's not going to help us. It's not going to show us that there are products which match with a little change in our search term. So that's basically as far as we can go with SQLite. But there's other tools to help us. There's tools like Sphinx, I heard, is a tool. There's a tool called Algolia, which is an external service, which we can just pump our data in, and then we can get some results. Or we can keep track of our own data and just pump our data from one data store into a search, a search-based data store. And for this workshop, we are going to use Elasticsearch. Elasticsearch is a search database based on Lucene. And it provides us with a REST interface to insert our data and to query the data that we have. So we are going to use this as our secondary data store just for search. So to give you a quick demo of what this can do, if we curl localhost 9200, if you can all do that right now. Curl localhost port 9200, we get a JSON response. And that's how Elasticsearch works. It works over HTTP and HTTPS, and it works with all our HTTP verbs. So we can do put requests, we can do delete requests, we can do get requests. And it's going to interact with us in JSON. So we can send JSON to it, and it will return JSON. So it's a super simple data storage. And underneath, it's going to use Lucene. And you can always see or check up which Lucene version it will use. And the tagline is, for search. So this database is used for search, and we are going to, it's built for search, and we are going to use it for search. We are going to keep our data in SQLite, a relational database, but we are going to expand our application by using two different types of databases, one for relational data and one for searching, right? So to do this, we need a way to sync our data from SQLite to Elasticsearch, right? We already have 32 objects here. We already have 32 products here, and we want to index them. We want to put them in Elasticsearch. So doing insert is called indexing. Why? Because Elasticsearch under the hood, or Lucene basically, because Lucene is under the hood of Elasticsearch, is going to create big tables, lookup tables for your items. So we put in JSON documents, and it's going to add a lot of keys into those big tables so we can quickly look up those documents. For example, if we have this Apple Airport Extreme and the description, then it's going to use, by default, it's going to see that this is text, and it's going to create an indexed item for airport, one for Extreme, one for Tim, one for Cooks, etc., all the way to Apple. And all of those indexes will point to this document. So whenever we type into the search bar, any word we see here, it's going to return us this document. So if we type in airport, it's going to point to 2 documents. It's going to point to document 1 and document 2 we see in this list. So that's how Elasticsearch works. It's basically a big bunch of arrays just in memory. So that's why it's pretty memory intensive. And we're going to see how we can improve our search by adding more items to those arrays. But we're going to look at that later. First, we need our data, our documents, from SQLite, which is a table store, into a JSON store, a document store. So to do that, we need a CLI command because we already have our documents. I'm going to call it reindex. It's already there. That's pretty efficient, right? So we have a CLI command which we can invoke with PHP artisan search reindex. Or with, if we type it shorter, since this is a Symfony-based CLI command, I can just do s:r. It's ambiguous, so reindex. Boom. s:reindex. So it's still empty here. It has a handle method, but I already spec'd out what we need to do. We need to create an SDK. We need to use the SDK to create the index. The index is basically what you can think of an index as a MySQL table. It's the opponent inside is Elasticsearch. So it's one index which you can use to search. We're going to put all our products in there by looping over all our products in SQLite and indexing them in Elasticsearch. So first step is we're going to create a client. Elasticsearch equals, we use the SDK, so we're going to use the client builder, create one, and build the SDK. I don't know why they made it this complex, but it's pretty simple. We're just going to copy and paste this line later. In ideal world, you're going to put this in the IOC container and resolve it from there. But we are lazy, and this is a demo, and we just want to use the Elasticsearch SDK. Since this is a REST API, you can also use Guzzle to do all your requests to Elasticsearch. But we don't want to learn all the quirks of Elasticsearch, so we're just going to use the SDK for now. So we got this SDK client, and we can use it to get all the indexes, indices. And we're going to first drop the old index by using indices delete. Index shall be products. And if I do this, it's going to fail. Why? Because at this moment in time, I don't have this index yet. It's like dropping a SQL table. I'm going to catch the exception and ignore it. Try, catch, import class, exception, and ignore it. Boom. So when I run it again, this is just always going to drop my products index. So the next thing we do is we actually create the index, and it's basically the same thing, but without the delete method, we just use the create method, create index. And if we do this, if we run this, index is create, and then index it shall be called product. We can use curl. We can use curl to take a look at our newly created products index. We don't need to give it a schema or anything. This is just JSON. We can drop in any type of document. And we can see that it's created with a timestamp. I don't know Unix time in my head, so I assume it's today now. It also has some shards and some replicas, but we will not take a look at that for now, or not today at least. Shards and replicas are basically for duplication, for scaling. So if you have multiple nodes, multiple Elastic servers, you can basically have a duplication of a document, and you can have different shards so that when a query comes in, only a few servers will handle your request, and the other ones will say, well, I don't have, other ones are already taking care of this, so I don't have to do this. It's basically for scaling. So we got this index, and now we're going to fill it with our products. If you go back to our CLI command, we can do Elasticsearch, index, and then we can index a document. But first we want to loop over all our documents. So we're going to use for each product cursor, which will return a PDO cursor style object, so we can loop over all our products without loading all products into memory at once. This is a memory easy way of doing this. So we're going to loop over all our products. Let me first import this with a cursor, and every single item is going to be a product model item for each row in the products table. So we're going to index this into the index called products, and every item is of type product. Note we can add a different type here. For example, we can put suppliers into the same index, and then we can search on suppliers and products at the same time. Note that we will get a different style of document. A product document might have different keys, might have a different structure than a supplier document. But for now, we're going to keep it simple and use the products index for products only. So all documents in this index will have the same structure, and the structure will be of type product. And then we're going to give it a body, which will be the effective document we want to insert as a JSON document. A product has a name, product's name. It also has a description. But we're going to also include the supplier's name. So instead of doing this in a relational way, like we do with SQLite, we're going to denormalize this and just insert the name right here. Instead of using the supplier ID, we're just going to expand this document with the names, description, and supplier name in this document itself, without having to use different documents or joins or whatever. This is a JSON document, so we can always use a different format here. So we're going to use product, supplier, name. This is super basic. You don't have to have any knowledge of Eloquent or ORM or whatever. This is just a product and a description, a product and a supplier, which is a relation, and the name of the relation. If we're going to execute this, what is this, 7 lines of code? It's pretty easy. We're going to dump all our data into Elasticsearch as JSON documents. Success. I didn't expect this to work at the first time, but okay. I can search all products by doing curl localhost 9200 /products/_search. And here we have it. We have some metadata about the shards, and we also have hits. In total, we have 32 because we have 32 products. And then we have a hits array with all the documents. Well, the documents are enhanced with _index, _type, _ID. they have a score and a source. And this source is the exact JSON document that we entered. It has a name, a description, and a supplier. So in here, the supplier is Juliana. Where's Ellen? There she is. So there's some documents for Ellen as well. And that's it. Now we have a search engine. So we can do curl localhost 9200 /products _ search and query for Ellen. If we run it, we can see all products that match with Ellen. By default, this will search for search on all fields. So if we have Ellen in the name or in the description or in the supplier, it will just return all documents. It's super simple. And it also returns the total number of documents. One thing I forgot, I see, is the IDs do not match with our IDs in SQLite, so we will never be able to reference back. So I'm going to change that and give it an ID. Product ID. And if you run it again, it should be fixed. That's fast, right? That's the basic advantage of using a CLI command. We can always rerun the command and see what the result is of the reindexed shape in Elasticsearch. Also note that it has a score, and by default it will sort or order on the score descending. So this is matching the best. This score is higher than this one, is higher than this one, is higher than the lowest one. The lowest one is this one. So by default, it's going to score documents and return the documents in the same order as a score, but descending. So we can use this super simple query style, HTTP style, REST style to query all documents in Elasticsearch. That's pretty neat. Let me get my notes here. So this is step number 2. Step number 1 was creating the MySQL query. Step number 2 was inserting all data in Elasticsearch. Note that we still use MySQL data. So if you go to the workshop, all products here are still in MySQL. They're still returned from MySQL. We are not hitting Elasticsearch yet. So that's the first thing we will change next. If we go to MySQL query, we can see that next to that, there's an Elasticsearch query as well, right? In there, there's some data already, some lines of code. But the most important ones, we will still have to implement ourselves. Create Elasticsearch client. If you go back to Reindex, we could just copy paste that because I'm lazy. Don't forget to import a class because that will bite your ass. And then the first step is we're going to get all the products from Elasticsearch, or at least the IDs. We need to know which products are there. And then we are going to retrieve all those documents or all those products from our primary data store, which is SQLite. So if you do Elasticsearch, we can search, right? Doesn't get much simpler than this. Elasticsearch, search in the index products for documents with type product. And then we need to add some pagination. Because we had some pagination in SQL, we also need some pagination here. There's 2 arguments here. There's size and there's from, which are kind of the same as limit in SQLite. So size is per page. I already have this here. Per page is 15. We're just mimicking the default behavior by the SQLite implementation we used. So we're going to use 15 again. And we're going to use from. It's per page times current page we're on, which is 1 based. So the first page is number 1, but we want to start from document 0. So we do 15 times 0 but because page is 1, we have to subtract 1. So page minus 1 is 0, so we will always start from document 0 here. Right? We can use a response, and the response is basically exactly the same as this one. It's an array or an array an array styled JSON document. So we can use hits, we can use hits total, we can use hits, and all those documents in underscore source to get all the products. So we got a response, and we want the total number of products returned by this query. So total equals response. If you take a look again, hits total. Hits total. Right? And then we want to get all our products from SQLite because there's more data there, like supplier ID, creation ads, updated ad. That's data that we didn't insert in Elasticsearch because we're not going to search on it. So what I want is I want all the IDs here. This ID, the next one, and use these IDs to query all the products. So IDs is an array, and I'm going to get it from the response, from hits. That's where all the objects are, all the returned objects. But then I want all the underscore ID fields. So underscore ID. I'm going to use some syntactic sugar. So I'm going to drop this in a collection, a Laravel collection. I'm going to pluck all the underscore ID values, all. This is just some syntactic sugar. You can copy paste this if you like. But basically this will return an array like this. IDs is, and then some UUID, another UUID, etc. So I'm going to use those IDs to get all the products. Equals product, find. I don't have to do anything crazy here. I can just drop in the IDs array. And this will return all products. Now I'm going to use these products into a new paginator object, which is a length-aware paginator. This is also some Laravel class, which I can instantiate with all the products, and then I'm going to just go over all constructor arguments, total, per page, current page, and some options, just to be able to get the same paginator object for my view. So I don't have to edit my controller, I don't have to edit my views, I can just use the same object here. So total, stop typing bullshit, per page, and also path needs to point to this path, which I already looked up here. So this code was already here. We created an Elasticsearch client, searched for some documents. Note that we are not using this search variable yet. We're just going to set up Elasticsearch to get all the documents, or at least the IDs, and then get all the models from SQLite and hit that or push that into our view layer, and our view layer will properly render all the pages and all the buttons. So we're going to get all products, dump it into a paginator object, also append the queue is search term, and that should work. One thing here, I want to inject that into my controller, products controller. I have a MySQL query here. I'm going to swap that out for an Elasticsearch query. In an ideal world, you would use IOC for this, but I'm just lazy here. I don't want to explain the IOC concept and the Laravel version of it, so I'm just going to change a couple of lines of code. So if you go to the workshop page, you can see that it returns properly all our products from Elasticsearch. Cool. Let's see. If we search all our products, we get Airport Extreme, Airport Express, Architecto Nisi. Wait. It's not in the right form. It's not in the right order. So the third one here, Airport Extreme, Airport Express, the third one, it doesn't match up with our third one here. Any idea why that is? Let me give you a hint. The find method, product find, in here, will just do a where in, or where IDs in. So it doesn't define the order. We have to sort them ourselves. But it's pretty simple. Just a couple of lines of code. So products equals products sort, which is like array sort, but with some syntactic sugar. A function to compare two items. So item A, item B. We're going to compare them in a anonymous function. And we're going to return whichever the different in position is. So position A compared to position B, right? We're going to use the IDs as well because we're going to make sure that we have exactly the same order as the IDs returned by Elasticsearch. So we just need position A here. Position A is array search for the ID of A, searching in IDs, the array of IDs returned by Elasticsearch, and have this extra option here so that it is a strict comparison. So we're going to search for position A and position B, position, thank you, IDE. Position A and position B in the IDs array, and we're going to compare them so that our products here have exactly the same order as our products returned by Elasticsearch. That's something that you have to do first, because if you start searching, then you're going to see weird results. Some documents are going at the top, but they're not supposed to be super, they're not super matching, so they're supposed to be more to the bottom. So with this search, we just fixed, with this sort, we just fixed the same order as returned by Elasticsearch. Let's verify if it works. Page 1. It doesn't work. Weird. Apple. Something's wrong. Anyone who can spot what is wrong? I'm going to take a sneak peek. Sorry? Yeah, Elasticsearch already sorts by score, which is always 1 here. But we get the results like this ID first, then this ID, then that ID. But we want to use those IDs to be used by our array of products from SQLite, so we have the exact same order. I'm going to look up what I did wrong. Oh, I know why. Jeez, phew. So when I have an empty search term here, I'm still going to use SQLite. Stupid me. So page 1, is still doing the same thing. Didn't fix it. Okay, maybe one more thing. I remove this, re-adding it. There we go. The architect goes second. So if we don't have a search here, we are still going to use Elasticsearch. The first one is Apple Airport Extreme, second one is Express, and the third one is the architect, blah, blah, blah. And we have the same order here. So it is working. Phew, saved my day. The next step we will be doing is, use a search term. We are still returning all of the data and not using the search term. So we're going to use something here. We're going to add the search term to the search query. For that, we need a body object, and the body object will have a query object in which we can do all kinds of things. We can do a match query, for example. Match. By the way, you can look this all up on the Elasticsearch documentation. So we can match, for example, the name and match it to search. This should work. So if we look for airport, it returns all airport items. If we look for DeLorem, it returns all DeLorem items, or at least it should. But it's not returning the ones with DeLorem in the description, nor is it returning items with Ellen as a supplier name. So we can match on multiple fields by using the multi-match query. Multi-match. The multi-match takes a query and some fields, an array of fields. And then we can pass in whatever fields we like. For example, name, I forgot ID, name, ID, description, and supplier. Okay. So we have a body, which is basically what we enter here. So this body query, and then we can do match, and then we can do name, and then airport. So this is basically the same query. We can also use multi-match, so we did that here. Multi-match query search, and on fields, ID, name, description, supplier. Let's see how it behaves. If we type in Ellen, we are going to see all Ellen supplied names. If we do DeLorem, we can see all DeLorem objects here. DeLorem in the name or DeLorem in the description. What about the ID? Nope. Why is that? By default, this just behavior, only items in this document will be used for indexing. The ID itself is just for reference. It's not going to be indexed. So that's pretty easy, right? We go to reindex and change the way our document looks. So we're still going to use ID here as a reference, but we're going to use the ID in the document itself. What do we need to do now? I changed this line of code. Reindex, exactly. If we take a look at sense, we're going to see that the document is enhanced with an ID field as well. So now we should be able to search on this part or any part, basically any part of a UUID. Doesn't work. I have no idea why. Let's search again. Sorry? Correct. We have a winner. So in the Elasticsearch query, I used _ID because I thought in first iteration I did that underscore ID would reference to the underscore ID of the document, but that's actually not true. Elasticsearch doesn't index that. But you can always enhance your document with an ID field. So if you use ID, we can look for that. If you use the middle part here, we can look for that. It doesn't show here because it's cutting it short. But OK, we can search for the ID as well. That's good. So we basically have kind of the same functionality as we had with SQLite, right? So we can search for the name, the ID, the description, the supplier. But what we also can do is we can search for Apple Airport. This is something that did not work in SQLite. It's also showing a keyboard item here, but that doesn't matter because it's on the bottom of the search results, and it matches part of our term, our search term, the Apple part at least. So it's scoring lower than these two documents, but these two documents are the ones we actually looked for. So that's already an enhancement over search in SQLite. We didn't have to do anything crazy here. We just have to dump our data in Elasticsearch and query for with a multi-match. That's it. Super simple. Let's see. The next part was, sure. What if this is failing because I did this? I'm going to put this back, and it should work now. OK. What if I add an item? Let me do that. So we have a keyboard, this time a UK layout for Apple, still super expensive for a keyboard. Yeah, where is it? Oh, there it is. Why is it there? It shouldn't be there. Because search. Actually, it's kind of weird. True. So if I search for keyboard, for example, it's not going to show up yet, right? If I go through Elasticsearch, the document is not there yet unless I re-index. So if I do that now, I can do that maybe once every minute, but that becomes quite a heavy operation. And since we're dropping all our index stuff and then recreating it, we might get some glitches, like a document not being there or simply no documents being returned. So we need to find something to fix this. If you've been to Marco's workshop yesterday, you learned about domain events and command handlers. We're going to basically plug into that. There's already one event here. Product was created, this event. And it's already being fired, but we are not listening to it yet. So next to events, we're going to create a new namespace for listeners. Listeners. We're going to create a new listener, which will be used to index every new document, every new product as a document in Elasticsearch. So it's going to be a class. How shall we name it? Any ideas? Index product. Let's call it index product. Super simple. Let's give it a namespace, app, products, listeners. If my PHP storm was set up correctly, I wouldn't have to do this. But I'm too lazy. This will be a listener with a handle method. So public function handle. And I'm going to handle product was created. Events. In here, I'll need to do three things. Create SDK, fetch the product, and index the product. That's up to you. Go ahead. Index your products. You can also check out version 1.0.5, and then you'll be at the same step as I did. 1.0.5. You should be able to do the first one. Just copy paste from the reindex command. If you do git reset 1.0.5, sorry. Should be git reset 1.0.5, maybe dash dash hard as well. Yeah. Should be here. I created it 3 hours ago. Okay, let's see. Are you sure it's this one? Yep. Should work. Let me try to fix this. Ref log. Maybe because the underlying commit is not there. Git fetch dash dash tags. Right, this one. And git reset 1.0.5 dash dash hard. Right. Now I have to redo this index product, I think. Maybe it's still there. It's still there. So create the SDK, or the client at least. You don't have to create an Elasticsearch SDK. That's how interesting the workshop is. Right. It's pretty easy. Just 3 lines of code. So we're going to steal at least one. That's what we do as programmers. Import this class. Fetch the product. Product is product. Product. Find event get product ID. And then we're actually going to steal a second line here, and that is to create this document in Elasticsearch. One more thing, we need to register this. Our framework is not going to magically find this, so we're going to say that in the event service provider, we're going to hint to the framework that when this event was called, we need to index our product. Just by referencing the class names, the framework will do the rest for us. So we got the product, and we should reindex it. Something went wrong. Yikes. We need to remigrate. So if we have our products, we want to create. Let's first go back and see that. PHP artisan search reindex. You need to make sure that there's no keyboards in here, right? Create a new one. Keyboard, if I can type it. UK layout, Apple, massively expensive. And then we should be able to search for a keyboard. There we go. If we even do this, search Q is keyboard. I massively use this Sense Chrome plugin to always be able to quickly check what is in my Elasticsearch. Because sometimes you have like these artifacts of your data being in one database but not in the other, but you still see it in the view, and that's super confusing. So I use this Sense plugin, Chrome plugin, to always be able to check what is in Elasticsearch. You can also use regular curl, but I use this one because it has like autocomplete, query, stuff like that. Cool. We do the same thing when a document is deleted. So if you do delete, it should delete as well. To do that, we need another listener inside this namespace. Delete from index. Let me quickly do that. Public function handle. Product was removed. Event. Copy the rest. Create SDK. And remove it. Elasticsearch. Import class. Delete. From the index products. Too much. I'm going to copy paste some more stuff because I'm lazy. So lazy. Delete from index products, type products with this ID. No body this time. Event gets product ID. This should do it, but I also need to register it. Event service provider. Register it. Remove, delete. Come on. Delete from index. I was too fast, and PHP Storm didn't give me the correct answers yet. Cool. So now I have 2 listeners who will keep my data in Elasticsearch always up to date. You can plug this into any application with any ORM or with any CQRS system. You can always keep it up to date. So don't mind the framework, don't mind the event system. You can always plug it into your application. So let's verify that it works. There's no keyboard in Elasticsearch anymore. Q is keyboard. And there's also no keyboard anymore in products. There we go. I was going to say a workshop is finished, but it's not. The next step is, you might have noticed while you were doing the exercise, but the search is still lacking some features. So, for example, when we do airport, for example, we do port space extreme. That did work in SQLite. It doesn't work anymore, but we can fix it. There's also one more thing. If we do airport, but we forgot some letter, for example the P, it also doesn't work yet. That's something we will fix right now. If you go to Elasticsearch query, we go to the multi-match. We can add some stuff here to make the search work better. The first thing I'm going to do is, for example, if we look for Delorum, maybe something else. Let me see. It should have worked. Oh no, there's different names now because I had to reseed. Let's look for sed. Sed is like a Latin word. And in the first document returned here, it appears in the description. But the second document actually starts with sed. So it would make sense if this one was more important to me than the first one. So in Elasticsearch, we can use something called boosting. And boosting will increase the score of a document so it appears higher in the list of returned results. And for this example, it would make sense if the name would match with the query string, with sed, then the document would appear higher. That wouldn't make sense for this one, right? Because description is just extra data. So how should we do this? How can we do this? It only needs 2 keystrokes. $2. By doing this, we increase or double the boosting score of the field name. If you use multi-match, it's going to still search for ID, name, description, and supplier to match. But we can make the relevance of the name field more important than the other ones. We can actually add a lot more, like give this a boost of 2 and this a boost of 3, and we can basically create an entire list of what is more important than the other, just by boosting some fields more than other fields. I'm going to revert this to 2 and this to 0 or 1. The default boost is 1. If we do boost 0, we basically null out the score, and the score of the document will always be null. So yeah, by doing this, we can increase the score if the name is matching. Note that it doesn't matter in what order we write this. If we write supplier first and then description, it doesn't matter. The score will always be the same, and it's always going to search on these fields. And it doesn't matter which order they are. So by doing this, we should see that the document with sed in the name should appear at the top. There we have it. Pretty cool, huh? Now let's show something else. For example, a long name like this one. But I'm a terrible writer, so I copy-pasted this. But if a client would come into my store and I would have to look for a document or a product, and I don't know entirely sure how to write it, maybe I misunderstood and I thought he said downtown or something with a U and an I, then I would have made a spelling mistake. There's actually a way to fix this and to make sure that whatever is matching pretty closely is still showing up, and it's called fuzziness. So if we add the parameter fuzziness here, fuzziness, I'm going to set this to auto for now. This will make some small alterations to my query terms. So for this query term, it's probably going to create this query term, and every word you can make with one different keystroke. So I'm going to leave out some letters here. I'm going to leave out the D, the N, and it's going to use all these words, these slightly modified words, to also search for the same documents. And it's going to use something called the Levenshtein distance. And the Levenshtein distance basically means I can make these words by using 2 modifications, or the 2 means the distance. So that if the distance is 2, I can make 2 modifications. For example, add a letter, remove a letter, or replace a letter. Those are all 1 modification. So what I did here is I made 1 modification here. And if I set fuzziness to auto, it's going to depend on the length of the term. So this word is about 10 letters long. And there's some scaling rules here. So if your term is only 3 letters long, it's only going to allow 1 change. If it's going to be 2 letters long, it's going to allow 0 changes. It's pretty hard to mess up a 2-letter word, to make a spelling mistake there. So something between 3 and 5 letters, it's going to allow 1 change, and everything longer than 5 letters, it's going to allow 2 changes. So if I change this and change this to an A and this to an X or something, or a Z, which is a silly typo, I still can get the same results. Let's see if it works. By the way, I changed 1 letter too many. It's still going to show up. So even I changed the U, the first U to an X, and the last U to an A, it's still going to show up the same results. So if I'm a loser and I type airport with 2 T's, I can still see airport extreme and airport express. Or if I type express with 1 S or express with 2 R's, it's still going to show up. It's still going to show my airport express as a result. So that is going to be a huge UX benefit, because a lot of people don't know how to use their fingers. And it's going to show me all of the relevant results within the Levenstein distance. So if you want to Google that, I have no idea how to write that, but Google will correct my spelling mistakes. It's called Levenstein distance. I'm Dutch, I'm Belgian, so it's going to show me the Netherlands version first. But this is basically the distance between 2 words described as character changes, or the minimum character changes to get from one word to the other. So by using Fuzziness Auto, which works pretty well for me, you might want to tweak it for you. It depends on your client and your users, basically. If you have silly users, you might want to allow a slightly greater Levenstein distance. So that's boosting and Levenstein distance. Let me see what's on the schedule next. In the meantime, go ahead and play with these numbers. If you allow maybe 10, you can get crazy results. So within 10 letters difference of said, you can get basically any word that's 3 letters long. So we can see that we have about, 19 results here just by typing said. All right. Okay, next one is a pretty complicated subject. If we go to Elasticsearch and we query the index, just curl localhost 9200/products, we can see that there are some settings about our index, but by inserting some data, it's also going to recognize some fields. So it's going to recognize that a document of type product will have some properties. Properties description, ID, name, and supplier. And it's going to auto-detect that it's of type text. That's the default behavior of Elasticsearch. What we can do is help Elasticsearch use this, or define what the fields are and what to do with them. For example, if we insert a product with text, name text, airport, and description, Tim Cook's cheapest Wi-Fi access point, it's going to use those pieces of text to create indexes in that big array. It's going to use Tim, Cook's, Wi-Fi, access, point, all those names, all those strings, it's going to use to index that one product. It's going to point to that one product. So if you type Tim or Cooks, it's going to always point to that document. Now we are going to help Elasticsearch to expand that list of array indexes to be able to better search for those documents. First, we're going to use a tool inside Elasticsearch to analyze a piece of text not related to this document. So we're going to use what Elasticsearch is using here for text is a standard analyzer. We're going to show what the standard analyzer is doing. So we're going to use curl localhost 9200 on product/_analyze. And we're going to use standard analyzer for the text. Let me grab one. This one. And you can see that it's parsing the text in different tokens. And those tokens are being used to fill up the arrays with the indexes. So preferendis, officia, ipsam, nulla, none. Those are the tokens used to reference to, used to search for an item in a Elasticsearch index. So if we type in preferendis, we can find this document, preferendis. But if we type only a substring of that word, we're not going to find it because the substring is not used as an index in those big arrays in memory in Elasticsearch. So to help us with that, we are going to use our own custom standard analyzer. And for that, we need to go back to our reindex command. And when we create the products index, we will define what kind of analyzers to use. And for that, we need some settings. And more specific, we are going to use some analysis settings. And in those analysis settings, we're going to define a filter. That's a filter to split up those words. I'm going to explain a little bit later. And we also are going to use or define our own analyzer. So the analyzer will be called custom text analyzer. This is something you can define yourself. You can create your own words here. And this custom text analyzer will be of type custom. Not kidding, it's custom. It will use a tokenizer. This tokenizer is what is used to split up the string. So the standard analyzer will use the standard tokenizer. And the standard tokenizer will split up based on characters that are not word characters. So if you use a \w in regex, that's a word character. And everything that is not underscored \w, it's not a word character. So a dot is not a word character, a space is not a word character, a dash is not a word character. So it's going to split up based on those string characters. So we're going to use the standard tokenizer because we still want to split up based on those items. But we're going to use some filters to improve on that. The first filter is one that is used by the standard analyzer as well, is lowercase. We still have to define that. The second one is Ascii Folding. So the first one is pretty logical. It's going to lowercase all characters. The second one is going to convert stuff like E with an accent or an I think it's a U with an umlaut or a, how do you type? I have no idea. This one, N, doesn't matter. Maybe like this, nope. Anyway, it's going to remove all accents from letters and it's going to revert them to their normal standardized ASCII characters. So that's going to be basically the alphabet and the nulls and the digits and yeah, basically also the uppercase, but we've removed those before, so we don't have to think about that anymore. And then we're going to use our custom filter. We're going to use a custom what did I call it here? Custom, let's call it filter first, and then we're going to explain what a filter does. So this filter is of type ngram. This is a filter built into Elasticsearch, and I'm going to explain what this filter does later. I'm going to give it two options, mingram 3 and maxgram 10. I'm going to use this custom filter here, custom filter. So if I use those settings, let's take a shortcut here, compact settings. If I use those settings to create my index, I can actually start using this analyzer. So if I use this custom text analyzer, and I'm going to use this as the text, you can see that this will have converted everything to lowercase. So the perforandis is now lowercase. It's going to split up by the non-word characters. And then the last filter, the custom ngram filter, will have created substrings of all these terms. These substrings are minimum length 3 and maximum length 10. So this will start with PER, PERF, PRFE, and it's going to continue up until the 10 length word, 10 character word length. And then it's going to start again, but starting from index 1. So it's going to start with the E, and it's going to continue from there. There's an alteration to this one, which is called the edge ngram filter. And if I run it again, I can show you. This will only start from the start of the word. So if we get to this word, we're going to jump to the next one. Officia. Office. Offici. Officia. There we go. And it's going to use all these terms as indexes in those big lookup tables in Elasticsearch in memory. So this is going to be quite memory intensive, but it's going to allow us to use those custom analyzers on those fields. Remember, we did we just inserted those documents, and it just detected that it was of type text, and it uses the standard analyzer. But we're going to use our custom text analyzer now to use all those substrings as lookup items in the arrays. So how to do that is we're going to define some mappings. Mappings equals array. And for product, we're going to basically copy this. Product, properties, description, type string, we're going to call it string, and set an analyzer. And we're going to do the same for name and supplier. We're going to wait a little bit for the ID, because we're going to do something special for that one. So product has some properties. Those properties are name, to begin with. Name is of type string. And we're going to let it be analyzed. So every document being inserted into this index will be looked at, and they will see, oh, it's a document of type product. We're going to look at the mappings and see, oh, there's some properties defined for that. One is being name, and we're going to take the name value, treat it as a string, and let it be analyzed by the analyzer called custom text analyzer. Cool. If you do the same thing for description and supplier, description, supplier, we will be able to use substrings to search for items. All right. Let me quickly finish this off, and then we will have a break. So whenever I insert this document, it's going to parse the name, description, and supplier to to all those substrings, and it's going to use those substrings as indexes in the array. So I need to re-index again, go to my product, and then I should be able to use this substring. It's not working, but that might be because of the fuzziness, so it's not really working now. Oh, I know why. So I referenced the settings here, but I forgot the mappings. Mappings. If I do it again, it should work this time. Let's find a crazy long word and use a substring, and that works. We can do the same thing for this substring. We can do the same thing for apple, erp, ord. Without having to finalize our search terms, we can already search for suppliers and the name and part of the description without having to fully type out the entire words. And with this, I would like to wrap up the first part of this workshop, and we will have some drinks now. Cheers. We'll just continue. Cool. So what we did before is we customized some mappings and added some analyzers so we could have extra tokens or extra indices in our arrays to look up documents. So we have more entry points into those arrays. We did that for the name, the description, and the supplier. But for the UUIDs, I want to do something special. So let me first create a name for the analyzer. ID type string. And analyzer shall be called custom UUID analyzer. What I want is, if you have a UUID, let me grab one, get products, search. If you have a UUID, I want to be able to search for everything from like 3 characters to 10, and even past that. I want to keep typing 9B, 9D, and get differentiating products, because this first prefix can be the same for 2 different products. So I want to keep typing without dashes, or with dashes if you want to. I just want to keep typing, and whether I enter dashes or not, I just want the UUID which I'm looking for to pop up. So for that, I'm going to remove the dashes. I'm going to write an analyzer to make it lowercase. I want to strip the dashes, and I want to make all the substrings all the way from 3 characters till 32, because a UUID has 32 characters without the dashes. So to do that, I need to use what they are calling a character filter. So a character filter, or char filter, allows you to modify or filter any character in a token. I'm going to call this UUID dash remover. And this will remove, remove all dashes from UUIDs in UUID fields with this custom UUID analyzer. So I'll call this custom UUID analyzer. And there's one existing character filter I can reuse with some options to make me do it to make it do what I want, which is called the it's a character filter called pattern replace. I need to learn how to type. So I'm going to define the pattern. Super simple. Dash replacement empty string. As simple as that. Now I can reuse this character filter in some analyzer. So like before, I have an analyzer. But this time, the type will still be custom, but the tokenizer will be white space. There's no white space in UUID, so that's why I use this one. I still want to do lowercase. I don't want to do Ascii folding because there's no weird characters in UUIDs. I don't want to use the custom filter, but I want to use the character filter that I just created. Character filter. And point it to, oopsie, what did I call it? UUID dash remover. So, I have a new analyzer, custom UUID analyzer, that is using a character filter called UUID dash remover, which is just removing dashes and replacing it with a empty string. I also want to use a ngram filter, like the one here. But this time I want to use it custom UUID ngram because I want to give it some special options. I'm still going to use the ngram, edge ngram. Minimum 3, but maximum 32. It's a slight alteration. So I'm going to use this filter again after using the lowercase filter. So let's see if this works. It did some. It inserted 32 documents, and when I use the analyze tool here, I can use a custom UUID analyzer. Maybe I need to call it analyzer. On a text, I will just copy paste some UUID here, and then I will see what the result is of the analyzer running over this UUID. So it starts with 69F, 69F3, 69FF, and it keeps on going without any dashes. The dashes have been removed, so if I use this string, I should be able to find this document, which starts with 69F blah 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 dash 9B 9D 45, etc. So if I copy paste any one of these tokens, I should be able to find the same document. There we go. You can also use the ngram, so you can skip one of the first characters. Now, so we altered our analyzers, and we used those analyzers, different analyzers for the UUID field, and one analyzer, custom text analyzer, for the name, description, and supplier. But we're still using multi-match. So if you remember, I added some boosting there for the name, and I added some fuzziness, which also kind of applies to this text here. So if I make one typo, two typos, it still matches. Do I want that? I don't know. What if the client says, well, there's too many products showing up, and I don't know why, because I did like 3 characters and it's showing up, or I made a typo here and it's still. For example, you have a lot of products here that start with 69F3 or something, 69F, and if you type 69F4, all those 69F products will still show up. So that's not really differentiating. So I want to reduce the fuzziness for the ID field. To be able to do that, we need to alter our multi-match. We need to pull out the ID field from the multi-match and do an OR, like a Boolean OR, either match with the multi-match or do a match on the ID field without or with less fuzziness. So let's go to the Elasticsearch query class. and take a look at the multi-match. We can use a query called bool. And this query called bool you can use to do an or an and operation. And you can nest those filters according to whatever you need. If you need some complex filtering and a lot of or and ands, you can use bool and bools inside bools and matches inside those. So you can create a pretty complex nested filter here. But for now, it's going to be pretty simple. It should match either one of these two filters. So I'm going to have two filters in here, and it should match at least one. So we need to specify that. Minimum should match. This is PHP, not JSON. Minimum should match 1. So if you have should with two filters, and you say minimum should match 1, it's effectively an or. It should match either one of these filters. You can also say must, and then it's an and. And it doesn't matter if you add a minimum should match or not. If it's must, it must match all of these filters. So we use should, and we say minimum should match is 1. I actually believe that minimum should match is 1 is the default, but I'm going to enter it or leave it anyway, just for being specific. So I have one filter here, multi-match. I'm going to still use that. And then another one. I'm going to remove ID here. And I'm going to create a match filter. I believe I'm missing a bracket here. Yeah. Match to match on the ID field. So it's either going to match on name, supplier, description, or it should match this ID field, ID search. Let me try this. I think I can also add fuzziness here. Maybe not. It's probably not going to work, so I'll have to look it up in the docs. Fuzziness is 1. Let me see if it works. Probably not. There we go. It doesn't match. Query doesn't support multiple fields. Found ID and fuzziness. So I'll have to look up the match query and see how it's done. So the basic form is match, the name of the field, and then the search term. I can add match, message, the query, and then some more information like fuzziness. So if I make this an object, instead of saying ID is search, I can say ID and then do query search. Oops. And bump this up and give it a fuzziness of 1, maximum 1. I can even reduce this to 0. Now it works again. So this is matching even though it says 69F3 instead of 69F4. So if I remove fuzziness altogether or set it to 0 to be very explicit, I don't have to reindex, it's not going to, it shouldn't show up here. Damn it, it is. I don't know why. Maybe fuzziness 0 is not allowed and it's defaulted to 1. Elasticsearch is pretty weird sometimes. Did I forget to remove ID here? Fuzziness is 10. Wow. It's basically matching everything. Nope. There must be a reason why. 69F4. For F2. It's still matching. That is super weird. Let's see, why is that? Search. Q is... This is kind of weird. Let's see if I got the documentation right. I'm gonna skip this for now because it doesn't really matter. Basically, what you see is we can do booleans, so we can add multiple filters and combine them with or and, basically by using should or must. So in here we have two filters, one match query and one multi-match. And we can combine them together as an or to query on either ID or the other fields, because those are analyzed differently and I want them to behave differently. That being said, we kind of went over some of the basic building blocks of analyzers and filters using match and multi-match. We can basically build anything from here. We can add more analyzers to different fields. We can modify this filters, this query object to match our client's expectations. And we can re-index everything from there. As soon as we touch the mappings or the settings or analyzers, we have to re-index. If we adjust the queries, we don't have to re-index. Speaking about the indexing, re-index. Do you think this is scalable? For each product, we're going to index a new document. What this will do is it will do a call to Elasticsearch, a round trip over the network, send the small document here, and come back. And Elasticsearch will, in the background, start processing this document. It has a queue built in with documents that still need to be indexed. So it's going to analyze those documents in the background. And if you push like a lot of round trips, it's going to take a while before they're effectively indexed. So it takes a while before they show up in your search. What happens is, if you're deploying and you changed something to either the settings or the mappings or this, this transformation from a ORM object to a JSON document, you need to re-index all your products. That's not really scalable. That may give you some downtime. Let me bump up the number of products to, let's say, 10,000. If I go to product seeder, I can make 10,000 documents, 10,000 products. PHP artisan, migrate, seed. Takes a while, but it's not this bottleneck that we're talking about. It's about this bottleneck. That's pretty slow. I can even put time in front of it. Then I can see that this will take approximately half a minute. Adding half a minute for 10,000 products to your deploy doesn't scale well. So if you have millions of products, it's going to take ages before this is re-indexed. And in the meantime, your users will see less products. So let's try this again. It took 22 seconds. Let's try this again. Search for Delorum. 41 pages. Try again. 70 pages. You see, during the deploy, our number of returned products is increasing. That's pretty odd. My client will not be happy with that. He's going to immediately send an email to my support at email address and say, there's something wrong with the search. It's broken. So we need to fix that. I'm going to give you a couple of assignments to improve this. You get to choose which assignment you take on first, but there's 2 ways to improve this. First, bulk inserts, right? Bulk inserts. So what we do now is we loop over every single product, and then we do a round trip to the database, and that is what's causing a lot of this time. We can at least reduce this by 50% just by using bulk indexing. You can choose the page size, maybe 15 documents at the same time, I don't know, or 50. You can make some graphs like what's the optimum based on my document size. And the second assignment, let me open up tasks here. The second assignment is to make sure that you create a second index, right, in the background, and switch out those indexes when you're ready with re-indexing. So before you delete the existing index, you have to create a new one, and you have to refer to the other one once you're finished. So you're still going to use the old documents. This might still have some side effects, but at least your search results will not vary as much. If you look for Elasticsearch index 0 downtime, you will find some documents and some ways to improve this. And then the third, but not, kind of different assignment is to add a Supplier Is Id Field to this. So if you say Supplier Is, and then I want to use, for example, my Apple supplier ID, I want to see only documents for this supplier. You can do this by adding more Boolean stuff in the filtering, and it takes about 6 lines of code. Once you know where they go, it's pretty easy. So yeah, you get to choose either one of those 3 assignments. So either add a supplier query filter, or fix the downtime issue with your indexes. There's a thing called index aliases. So if you create a new index with a hashed version of the name based on the timestamp, you can add an alias called products to that index and remove the alias from the old index to switch to the new one. Is that somewhat clear? So you have 2 indexes, and the old index has an alias called products. And once you're finished with re-indexing the new index, you can remove the alias for the first one and assign it to the second one. So essentially, when you're calling a search on a index called products, it's going to look for an index called products. There's no index called product, but there's an alias for products. And it's going to assign or look at a different index depending on where the alias is assigned to. And the third assignment is to use bulk inserts. If you have any questions, I'll be walking around and helping you. You have 1 hour. So the first task was making sure that there's a supplier equals supplier ID, and we need to make that work. So if we go to the products controller, we can get the supplier from the request and pass it on to the search method on the Elasticsearch query. And then in here, we do some if-else logic, and we build up a filter to be used, whether or not the supplier is applied or the search is applied. We might do some other things. So this is the old query in here, and the new query, the supplier query, is this one. It's the term filter, and this term filter is used when the supplier ID needs to match exactly with this value. So if both are supplied, we need to do a bool, and they both must be returning 1 or be returning true. If not, we do some if-else queries, and we supply either one of both or 0. And then we do some querying, and then the result is returned. Last but not least, I also append the supplier query string to the paginator. So if we do this, we can successfully query for all Lavon supplied products, and we can do some even more advanced filtering within that result. Of course, when I enter this form, I should have added a supplier equals query string here. So that's term query. I also had to add it to this reindex command because I have some extra information here. I have a supplier ID. And instead of using type string, I use type keyword. So it's not going to analyze this. It's just going to use this keyword exactly into one of those big arrays to look up those documents. So there's going to be like 6 of these IDs in that big index, and they're going to point to a list of products per supplier ID. The other thing was bulk inserts, and the bulk inserts work like this. We have Elasticsearch bulk, and then we need to add a list of actions, and the actions are basically every action has 2 objects in this array of actions. The first is the action, the individual action, and the second one is the body of the document that you want to insert. This is kind of weird, I know. It's Elasticsearch, it's sexy because it's REST and all of that, but there's still some quirks like this where you have to enter 2 rows in an array just to insert one document. It's pretty weird. I would have loved to have like a body in here, but sadly that doesn't work. You have to do something like this, and if you do count action is greater or equals than 100, which means my page size is inserting 50 documents at the same time. It's kind of weird. I can also write 50 times 2, but you know. The other thing, I didn't get it to work, sadly, but some of you did. If you look for index alias and 0 downtime, you can find that you can create any kind of index name, like products-timestamp, and then you can create an index products and point it to that index. And then all searches to the products index will go to that products-timestamp index. And if you create a new one while deploying, for example, you can create it products-a different timestamp and update the alias, move it from the old one, and move it to the new one at the same time with these actions. So you have a remove action that removes this my index. For us, that would be products because we search on the index products. And we move it from products old one to the product new one. There were some people over there who made it a little bit simpler. Instead of using timestamps and having to look up the old timestamp, the old index, they just said products old and products new, and they switched between those two. So sometimes they would move from products new to products old, kind of. It doesn't matter, correct. Yeah, I know, Ivo, I know. 2 seconds. 2 more things. You can add some highlighting as well. So when we search for things, for example, in this search bar, I can type index document, and it will highlight doc values, doc values, long doc, blah, blah, blah. Those things in bold are highlighted. You can do that with Elasticsearch as well by using this highlight item here in the query. And this will help with highlighting text from fields, from documents, so you can have a better understanding of why something matched a query. One last thing is faceted search. For example, if you would have a list here with all suppliers, we would be able to add some counters. For example, there's 5 Apple products, there's 20 Ellen products, there's 1 Tina product, and if you would downsize our selection, those numbers would update. That is what we call faceted search. For example, if we enter movies here, then the number for Belgian movies would be smaller. Because if you would select books and movies, the total number would be bigger. You can actually do that with Elasticsearch by using aggregations. And you can just check out this blog post by Made with Love to find all aggregation opportunities and to make filters like this. I think that concludes my workshop with 4 minutes over time. Sorry, Ivo. If you have any more questions, feel free to come up to me and have a chat. We also have a group picture right outside on the smoker's terrace.